Finding voltage on a water pipe when you expect everything to be grounded can be perplexing. There are several potential causes and corresponding troubleshooting steps to consider. Firstly, a miswired neutral is a common culprit. Verify that the neutral from the service entrance is correctly connected to the neutral bus bar in the electrical panel. Ensure that the neutral is not accidentally connected to a different terminal, such as a hot terminal. Secondly, a faulty electrical device connected to the circuit could introduce voltage. Identify and disconnect all electrical devices connected to the circuit where the voltage is present. Replace any faulty devices and recheck for voltage. Thirdly, corrosion or loose connections can lead to voltage discrepancies. Inspect all electrical connections, including those at the water pipe clamp, grounding rod, and bonding wire. Ensure that all connections are tight and free of corrosion. Fourthly, a ground loop might be the cause. A ground loop can occur when multiple grounding paths exist. Check for any additional grounding wires connected to the water pipe or other metal objects. Remove or relocate any unnecessary grounding wires to eliminate the loop. Fifthly, consider water pipe segmentation. If the water pipe is segmented, ensure that the segments are properly bonded together. Use a bonding clamp to connect the segments and provide a continuous grounding path. Sixthly, plastic water lines can interrupt electrical continuity. Plastic water lines can interrupt the electrical continuity of the water pipe system. Verify that the plastic lines are not interrupting the grounding path. Install a U-for ground or other approved grounding method to bypass the plastic sections. Seventhly, an open ground or neutral is another possibility. Use a voltmeter to test the continuity of the ground and neutral lines. An open circuit between the panel and the utilities or between the panel and the grounding system can cause voltage on the water pipe. Eighthly, induction can play a role. The magnetic field from nearby electrical components can induce voltage in the water pipe. Move electrical components away from the water pipe or install shielding to reduce induction. Ninthly, stray voltage can be caused by a number of factors including grounding issues, faulty appliances, and improper grounding of equipment. Use a voltage detector to check for stray voltage and identify the source. As part of additional troubleshooting, disconnect the service entrance and measure the voltage between the water pipe and the bonding wire. If the voltage is still present, the issue may be external to the house. Inspect the utility connection and ensure that the neutral is properly connected. If the source of the voltage cannot be identified within the house, contact the utility company to investigate the issue. It is also prudent to consider the materials used in your plumbing system. If you have a mix of copper and galvanized steel pipes, galvanic corrosion can occur, potentially creating a voltage difference. Check for any signs of corrosion, especially at joints between dissimilar metals. Bonding these dissimilar metal sections together can help mitigate this issue. Also, be mindful of any recent electrical work done in the house. Incorrect wiring during renovations or additions could inadvertently create a path for voltage to appear on the water pipe. Review any recent electrical modifications and verify their compliance with electrical codes. If the house has undergone any significant structural changes, the grounding system might have been compromised. Ensure that all grounding connections are intact and properly bonded. Consider adding supplemental grounding electrodes if necessary to enhance the overall grounding system. In some cases, the problem might not be originating within the house but rather from a neighboring property or the utility grid itself. Voltage imbalances on the grid can sometimes manifest as stray voltage on grounded metal objects. Document the voltage readings on the water pipe over a period of time to see if there are any patterns or fluctuations. This information can be helpful for the utility company to diagnose the issue. Remember that safety is paramount when dealing with electrical issues. If you are not comfortable working with electricity, it is best to consult a qualified electrician to perform the troubleshooting and repairs. Attempting electrical work without proper knowledge and precautions can be dangerous and potentially life-threatening. When measuring voltage, use a calibrated voltmeter and ensure that it is properly grounded. Wear appropriate personal protective equipment, such as rubber gloves and safety glasses, to minimize the risk of electrical shock. Before disconnecting any wires or components, turn off the power to the affected circuit at the main breaker panel. This will help prevent accidental contact with live conductors. Use a non-contact voltage tester to verify that the circuit is energized before proceeding with any work. When inspecting connections, look for signs of overheating such as discoloration or melted insulation. These are indications of loose or corroded connections that need to be addressed. Clean any corroded surfaces with a wire brush and apply an antioxidant compound to prevent future corrosion. When tightening connections, use the appropriate torque specifications to ensure a secure and reliable connection. Over-tightening can damage the components, while under-tightening can lead to loose connections. If you suspect a faulty electrical device is causing the voltage on the water pipe, try isolating it by unplugging or disconnecting it from the circuit. Then, recheck the voltage on the water pipe to see if it has disappeared. If the voltage is gone, the disconnected device is likely the source of the problem. When dealing with ground loops, try systematically removing or relocating grounding wires to see if it eliminates the voltage in the water pipe. However, be careful not to compromise the overall grounding system of the house. Any modifications to the grounding system should be done in accordance with electrical codes and best practices. If the water pipe is segmented, use bonding clamps that are specifically designed for grounding purposes. These clamps should be made of corrosion-resistant materials and provide a secure electrical connection between the pipe segments. When dealing with plastic water lines, consider installing a UFA ground or other approved grounding method to bypass the plastic sections. A UFA ground involves encasing a length of bare copper wire in concrete, which provides a reliable grounding electrode. If you suspect an open ground or neutral, use a multimeter to test the continuity of the ground and neutral lines. The multimeter should show a low resistance reading between the panel and the grounding system or between the panel and the utilities. If the resistance is high or infinite, it indicates an open circuit that needs to be located and repaired. When dealing with induction, try moving electrical components away from the water pipe or installing shielding to reduce the magnetic field. Shielding can be achieved by enclosing the electrical components in metal enclosures or using magnetic shielding materials. If you suspect stray voltage is the cause, use a voltage detector to check for stray voltage in various locations around the house. The voltage detector will indicate the presence of voltage without making direct contact with the conductors. If you find stray voltage, try to identify the source by systematically turning off circuits or appliances and rechecking for voltage. If the source of the voltage cannot be identified within the house, it is possible that it is originating from a neighboring property or the utility grid itself. In this case, contact the utility company to investigate the issue. They have specialized equipment and expertise to trace and resolve stray voltage problems. Remember that troubleshooting electrical issues can be complex and challenging. If you are not comfortable with any of these steps, it is best to consult a qualified electrician to perform the troubleshooting and repairs. They have the knowledge, experience, and tools to safely and effectively resolve the problem. The NEC, or National Electrical Code, provides comprehensive guidelines for electrical installations and grounding systems. Consult the NEC for specific requirements and best practices related to grounding and bonding. Ensure that all electrical work is performed in accordance with the NEC and local electrical codes. Regular inspections of the electrical system can help identify potential problems before they become serious. Schedule periodic inspections by a qualified electrician to ensure that the electrical system is safe and up to code. By following these troubleshooting steps and safety precautions, you can effectively diagnose and resolve the issue of voltage on a water pipe. Remember to prioritize safety and consult a qualified electrician if you are not comfortable working with electricity.